grade 12, we're still finishing off our first date 2024 question for number 15. So we're now doing 3.2. So they're saying consider the infinite geometric series. We're given those terms. So T1 there is 2k minus 5. So it's a plus now because the series. So it's 2k minus 5 squared and so on. So the first question they're saying for which values of k will is the series convergent? First step, we're talking about convergent. So we know that convergent series, the condition, you write the condition down, r must be between -1 and 1. You get a mark just for writing this. When they say convergent geometric and geometric series, always write this as a first condition to show that you understand what is the definition of convergent. Now we must find our r and substitute it here and ensure that our r is between -1 and 1 by choosing a good value of k, because k can be any number here, but I want k which will make r to be between -1 and 1. That's why they're saying for which values of k is this series convergent. They want the k that will make this series to converge, which means that it will make our r to be between -1 and 1. What is our r first? Our r would be T2 over T1 or T3 over T2, but T2 is that one, so it's 2k minus 5 squared over 2 times k minus 5. If we divide this, you're going to see that the 2's they cancel out. We're left with k minus 5 squared divided by k minus 5. These, we've got the same base, which is k minus 5, so we subtract exponents, divide in same bases, so it's going to be 2 minus that exponent, which is 1, so we're going to be left with k minus 5. What we do now, we take our r, plug it in here, so we have got k minus 5. Now we have -1 and 1. We want to solve for k. How do we solve for k in this case? So we have a 1 here, we have a -1. So we're left with the k, so we're going to add 5, right? So because if you say 5 goes to 5, it's gonna cancel out this -5. So then you say plus 5 because it's an inequality, so you must do everything on all the sides. Then plus 5. What we have now, we are left with k here. Why? Because those two, they have cancelled out. So we are left with k is between, so here we get the -1 plus 5, which is a 4, 1 plus 5, which is a 6. Now with k is between 4 and 6, our series will be convergent, meaning that sum to infinity will exist. Then 3.2.2, they are saying if k is 4.5, calculate sum to infinity. So now they are saying if k is equal to 4.5, which means if k is 4.5, if you convert this, we'll just punch it as it is in a calculator, and you can see that this k is actually between 4 and 6, so we know it's going to be convergent and it's going to have sum to infinity, because if it's not convergent, then there will be no sum to infinity. Now if k is that, they're saying we must find sum to infinity, but before you find sum to infinity, you must find our actual terms. So meaning that the first term is going to be 2, substitute k, so it's 2k minus 5. So what is k? K is so it's 2k is 4.5 minus 5, that is t1. T2 is 2 times 4.5 minus 5 squared, and then the last term would be 4. In fact, we don't need all these terms. I'm not writing about it, but it's fine. Only need a and r. Okay, but let's just find the first term. It's going to be 2 times 4.5 minus 5, which is going to be -1. T1. I'm gonna leave the other terms, but you can do the same. So we know that a is -1. What will be r? R is k minus 5. So it's going to be 4.5 minus 5, which would be negative 0.5 or negative half. Now we go to our S infinity formula. A is -1 over R is negative 0.5 minus 1. Then if we simplify this, we have negative 0.5. We have -1 divided by negative 0.5 minus 1, which would be 0.67. That would be our sum to infinity. And then the last question, 3.3. Let me just copy and just put it here. That is our 4 marks question. They're saying the three numbers are in the ratio 1 is to 3. So these numbers are in the ratio of 1 is to 3 is to 10. And then if we subtract 20 from the third number, we get a geometric sequence. What are the three numbers? Okay, so first things, let's underline geometric sequence. If we subtract 20, we get a geometric sequence. But initially, we've got this ratio. Let's just think about the ratio again. A ratio is not the same as the actual. Now, for example, we can say the ratio is 1 is to 2. Maybe the age of learner A and learner B. So we say these are the ages. The ratio is 1 is to 2. The ratio could, the actual ages could be 10 and 20, because the ratio here, if you divide by 10, you're gonna get 1 is to 2. Or it could be 7 is to 14. Then A could be 7 years, then B could be 14. Or it could be 9 is to 18. So it can be any number. So we don't know what exactly it is. So that's why now we don't know what factor is used to multiply this. It could be a 10, that if you say 10 and 10, or it could be a 7, or it could be a 9, or it could be a 5. So what we do now when we have ratios, we just write them like this. Because we do not know this factor, we call it k. We call it k, we call it k. Why? Because that factor here is actually 9. Because 1 times 9, that is just rewriting 9. But if you rewrite 18, it would be 2 times 9 again. That's how we get the ratio 1 is to 2. The same here, it would be 1 times 10 is 2 times 10. That would be the ratio here. Then the factor would be 10, the common factor. So we don't know the common factor here. So we've done step 1. Then they are saying now if you subtract 20. So now this gives us the actual values now, not just the ratio. The ratio is 1 is to 3 is to 10, but 1k, 3k, and 10k is now an actual number. It's actually like this. Now that it's 1 is to 18, but we don't know what is the k. So what they're saying now, if we subtract 20 from that number, so let's do that, then we get a geometric sequence. So we have 1k, what we do now, we subtract 20 on the last one. So on the third number, yes. So meaning that what we end up having is a geometric sequence. We have 1k. So write it as a sequence now. We have 1 k is to 3 k is to 10 k. But now what we do is we subtract 20, and we get a geometric sequence. Meaning that this would be t1, that would be t2, that would be t3. Now we can find our r. So we know that if this is a geometric, I want to find k, it's a geometric series, the same as what we did in the second question, where we wanted to find x for our, which was this question here. This question, we need to find x. So we just use the definition of an arithmetic sequence, which is the common difference. So we're going to use the common ratio here. So it's going to say a geometric sequence. So t2 over t1 is equal to t3 over t2. What is t2? 3k over k. And then what is t3? 10k minus 20 over 3k. Cross multiply, gonna get 3k squared is equal to k times 10k, gonna get 10k squared. K times minus 20, get minus 20k. And then we move everything to one side. 10k squared, that's that. Let's transpose. Okay, let's just leave it like that. Let's have a 0 here. Then we have 3k minus that, we get a 7k squared minus 20k. Take out the common factor of k, you're left with 7 minus 7k minus 20. So we get k is equal to 0, or 7k is equal to, or 7k minus 20 is equal to 0. Then if you solve this, you'll get that k is equal to 20 over 7. But k cannot be equal to 0, because if k is 0, we're going to have undefined here. Therefore, our k is that. Just use the definition of, I think maybe the tricky part was just to move from that to that to that. Once we are here, it's the normal way we work with geometric sequences.